So we got into conversation this week amongst both growers and ourselves in extension about what the meaning of some NEWA output was, whether we needed to spray for um, spray strep for Fireblight, basically. And it got me to thinking, and so I decided that I would show you a few things about the output on NEWA and how it works. And I want to start it off by saying that it's important to remember not to just blindly follow these decision support systems any more than you want to blindly follow your GPS. So here's what we were looking at today, I think, or close to it. It, as you can see, not much going on, but I want to focus on this upper area of the output and this will evolve as we go along. When you're setting up NEWA, of course, you want to make sure that you put your history in. You've got basically three choices, and we recommend using the middle choice. Fireblight occurred in your neighborhood last year. You can have it ramped up to active if in fact it is. I would not use the lowest no Fireblight in your neighborhood. So if we focus on the upper part of this chart, there are basically two models. There's one which is this Cougar Blight, and then there's the other, the infection potential EIP value. And in each of these, there are two lines. One line is for an overall risk rating, and that's on the top. And so you see things like low and moderate here. And the other line is a temperature-based risk rating, but it's not at all clear, what those numbers mean because they're both numerical. And so we'll talk a little bit about that. Let's start with Cougar Blight. So here's our Cougar Blight line. You can see the low rating across the board, and then a set of numbers for the 4-day degree hours. If we start just looking at the ratings, there's 4 possibilities. Either low, don't worry about anything. Caution, be ready if warm, wet weather hits. High, you better spray strep if there's any rain predicted in the near future, or if you missed it, just after. And then extreme, just spray strep. Second, we have here is the numbers, and this is basically the Cougar Blight model accumulates degree hours for the previous 4 days during bloom and uses a base of 60 degrees Fahrenheit. We're doing this in bloom, so the flowers have to be open, and then the data along with that history evaluation that you gave is used to give that risk evaluation in the first line. So if this shows you what Cougar Blight is basically doing, at least the version in NEWA. The Cougar Blight itself in Washington State has changed, and that will be adapting that and putting it into NEWA over the next year or so. But this is the way it stands now. You can see there's, for each risk, there's a set of accumulated degree hours, which are thresholds for each of 4 risk ratings in the case of the real Cougar Blight, which has been stripped down to 3 for the NEWA version. If we look at the one that I've suggested people use, then you see here we have 0 to 150 being low. So in other words, anytime you're below 150 in terms of these degree hours, the risk should be low. Once you hit 150, it gets to be moderate, and then up here, 300 or above, high or extreme. this, if we looked the day before that first chart that I showed you, this is what we were seeing in Cougar Blight. And it had managed to get itself up to 150 4-day degree hours, which was just hitting that caution line. And therefore, then NEWA goes and makes it into a yellow color with the overall blight rate, risk rating of caution. This is a different set of data from Belchertown in 2017 to show you a couple of things. One is how quickly these risk ratings can change, and also that these numbers can go way up there. So this would show you a very extreme situation in terms of Cougar Blight.
Hey, Dan, just want to be clear that the Cougar Blight model does not take into account wetting. That extreme just means the infection risk is extreme if you get wetting, correct, Dan?
And that's true for pretty much everything, but you'll see there's some wrinkles when we get to the next bit. But absolutely right. Needs to be wetting. So here we are again back looking at a different set of, we're back to today's version of the data. And if we focus on what NEWA calls infection potential, or EIP value, those are the two things, the two ratings there. That in fact is an implementation of the model MaryBlyt that was done for NEWA. And so again, we get these 4 risk levels in that top line under infection potential, which is basically the same as Cougar Blight. They use a few different words, a couple of different words. Moderate is caution and infection is extreme. And there's subtle differences there, and I'll explain in a sec. If we look at the infection potential rating, MaryBlyt and NEWA use 4 factors to determine what this risk rating is. It explicitly says flowers have to be open. That's one thing. Average temperature has to be over 60 degrees Fahrenheit. That checks another box. And then there's the wetting. And for MaryBlyt, that checks a 3rd box. And then the accumulated degree hours since bloom, which is the EIP value, which you will see they're also tracking down below. So if you look at those 4 things, remember bloom, the degree hour threshold, temperatures over 60 degrees Fahrenheit, and wetting, then if there's we're only looking at whether the trees are in bloom, that's the only time you'll get a low overall rating in the infection potential part of NEWA. It doesn't start to get into higher levels until one of the other 3 things get checked off as well. So you can get moderate ratings if any one of these 3, but just one, are exceeded. If 2 of them are exceeded, then you'll get a high rating. And if all 3 are exceeded, then you've got infection. So by default, you have to have wetting in order to get to infection. But on the other hand, you can have wetting and bloom, and that's going to just be moderate. I think that overall, these risk ratings, the so-called infection potential in NEWA, are the least valuable of those things that it presents for Fireblight evaluation. If we move down to this EIP value, I think that's more valuable. It stands for epiphytic infection potential, which is a way of saying sort of the population estimate of bacteria on the surface of the plant. And in MaryBlyt, it's tracked from when buds break. It's based on degree hours based on 65 degree Fahrenheit threshold. I've given you an example here where we're looking at if for just 1 hour it was 70 degrees Fahrenheit, then we subtract our base of 65, so we have 5 degree hours. If that, say it's nice and even and 70 degrees for 12 hours, then we get 5 degree hours for each of 12 hours, or a total of, 60 degree hours. My math wasn't too good this afternoon. And so that's going to actually translate to an EIP of 30. A conservative approach would be to say, if EIP is over 70, then you need to use strep if there is any wetting. And so that's really I think the thing to watch in this lower box is what's the EIP doing. Now, when we look here at our recent data, then on the 3rd, we saw this EIP was not going up very high. It was 34. Yet we have this lit up in orange, the infection potential, and it's rated as high, which gives you pause for thought. Should we do something? Well, probably. Geez, I don't know. And so I think that's based largely on the fact that it was predicting that the average temperature was going to be over 60, or it had been over 60 up to that point in the day, and then it dropped later. And so overall, so far, the infection potential rating in general was high, though EIP was telling you, nah, don't worry so much about it. So if you went ahead and sprayed, then it's not really a problem. You spent some money on material and your time, but it's not going to hurt the trees. So it's the kind of error that's less costly. There are other problems. So here's our data from 2017 again, and I'm pointing out an EIP value of 256, which is way up there. Yet what we're seeing in terms of overall infection potential in that line is only moderate. Not enough of the boxes got clicked to even bump it up to high, and certainly not extreme or infection. At the same time, we look at Cougar Blight, and it's showing, hey, these numbers are way up, and it's ranking it as extreme. So in that you're getting an EIP of 256 and these values up here in Cougar Blight, I'd say that's a very risky situation. And if there's any chance you're going to have a heavy dew, maybe even in a situation like this, if the relative humidity is going to be running 100% for a few hours in the night, I would be concerned at least about my most vulnerable trees. So I would just sort of say, to heck with this yellow moderate business. It really doesn't tell me much.
Hey, Dan.
John, is that you?
Dan, yeah. Let's go back quickly. So in your previous table, there was 2 conditions that would give you that moderate level, right?
There were 3.
I thought there was 2 with moderate. Low was 1. No.
Can we go back to
3?
it?
Well, I thought it was 2, but just what would be the 2? Obviously, the degree hours is very high.
Yep, degree
Wetting?
hours
Would it be wet?
Also, it does take into account how high the EIP is, and so that high EIP checks another one. I think what's going on there is actually there's only probably the EIP is high, plus it's in bloom. It's probably a cool day and there's no moisture. So only 2 things get checked. So it's only moderate.
All right. It's a little bit confusing in that case. All right. Need to look at that further.
Okay. Does that make sense? If it was a
the higher EIP value can check the box even more than a lower EIP value?
No, it's threshold based, but take a look at this.
We can take this up later.
Yeah, okay, let me just say it's probably a dry, cool day. And so only 2 things get checked. So the overall rating is moderate. I don't think that tells you a lot because you still got a lot of bacteria. If it gets wet, you're in trouble.
Okay, good enough.
Okay, so actually that winds it up. If people have questions,
The question was from Tom Nishway. So I have this question too. So Tom is asking, if you spray a fungicide, can you cause a Fireblight infection? So my question is, I also have that question, but I also would like to know about the relative humidity thing that is suddenly being bandied about. Do we have any information that that tells you that indeed a high relative humidity or a spray of fungicide, for example, could cause infection?
there's no good hard evidence for either one. Um, there are stories and situations that point in that direction. Um, I've the and it's not so much a fungicide spray per se is it's just any spray whatsoever that you put out there, with the obvious exception of strep. Um, and there's enough moisture if extreme conditions exist to wash bacteria down into the flower, which is what starts the infection. As far as the high relative humidity, I think those such situations, you it may be that we're just not seeing that there was actually a dew and there was enough enough dew formation to cause wetting. Um, that's
So
that's what I think is happening in reality, but it's not getting caught in the weather data.
right. Okay. So that was what I was going to ask. The dew, not seeing the dew assumes that we are either able to physically monitor it using a sensor or model it somehow.
Yeah. And if you want to be most effective at reducing the bacterial population, then do your sprays in the evening because the Fireblight bacteria do most of their reproduction uh, at nighttime, not unlike other organisms. But the bacteria really, if you suppress their population in the evening, then they don't build up to a high level. If you try to do it in the morning, they've already developed to a high level. So that's the optimal timing on that. Now, having said that, um, don't be spraying a lot of extra strep just to keep your populations down. I think we're much better if we're sort of looking at managing surface bacteria to look at copper sprays.
Great. Thanks, Dan.